I didn't turn the microphone on. Can you hear me now?
Yes, I can. Can you hear me?
Hello? Hi, Robert, can you hear me? Okay, great. Okay, well, let's go ahead and get started. And I see one more person join, so that's great. I want to take your questions first, and then I have some example. I have 3 examples, actually, I'd like to work out, but I can work out more or less or whatever you would like me to cover. So is there something pressing or that I really don't want to go too much over confidence intervals because the hypothesis testing is what's due, well, it's due tonight, but Saturday you'll have some more problems. So I'd really like to cover that. But let me take specific questions first, or tell me what you want me to cover. Just chat, or if you have your microphone, just talk, and you can interrupt me at any time. Let's see who's here. Alicia, welcome, Alicia. So, do you want me to just start? Charmaine's here too. Do you want me to just start? Okay, yeah, call in. You said connect with your phone. Okay, stop me at any time. I can't see you when you raise your hand, so just go ahead and chat. I can see your chat. And all right, what I want to do is let me switch to my Word document. I can't type this out on here because it won't let me type. So I'm going to go to my, let's see. See if you can see this. Can you see that? Oh, wait, share.
Hello.
No. Okay. Let me, just a minute. That, can you see that? Well, then if I go back, yes. Okay, let me go back to it then. All right. So here's the first question we're going to talk about, and I'll give you a minute to read it. It's been reported that the average credit card debt for college seniors at a college bookstore for a specific college is $32.62. The Student Senate at a large university feels that their seniors have a debt much less than this. So it conducts a study of 50 randomly selected seniors and finds that the average debt is $2,995. And the population standard deviation is 1100, $1,100. With a level of significance of 0.05, is the Student Senate correct? Okay, so I want to go through my 5 steps. Like I said, I can't copy and paste this problem onto, and I can't see the chat if I go to this Word document. So let me give you a minute to copy some of that down. And we're going to go through the 5 steps. Well, I guess we could just do it here. So what is, well, then I can't see you asking questions. So I want to go slowly because I want you to answer the question so you understand it. I wish I could just copy this and put it into the whiteboard, but I don't see a way to do this. So I'm going to go back to the whiteboard.
Like an high school geniuses that are in my class.
Okay. Step 1. We have to decide what the null is and what the alternative is. The null is always has the equal sign. It doesn't matter what it says or what your hypothesis is, it always includes the equal. So if you look, I want you to tell me what we should do here, because it says the student senate feels their seniors have a debt much less than this. That is a significant sentence in this problem. Okay, the student senate, that is the okay, that's the example. The student example, I guess, is the 50 selected seniors is our example. But they think that their seniors have a debt much less than this. So you're not going to put, okay, I'm just going to say mu less than 3262. That is not, you can't do that because it doesn't have the equal sign. So that automatically means that that is your alternative hypothesis. You don't have to do the null first. Okay, so you have to get that out of your head, that you have to do the null first. So mu, remember, is the mean, and our hypothesis is that the mean is less than 3262. And anytime you don't understand, then you chat with me, okay? All right, so that automatically means that your null is the mean must be greater than or equal to 3262. Okay, so this is not as hard as you're making it. You take the sentence that would have less than or greater than or not equal to or equal to, and you decide that first. And the null isn't the first thing you have to decide. This sentence tells us the student center at a large university feels that their seniors have a debt much less than 3262. So because it's just less than, that has to be the alternative hypothesis. The null is automatically the opposite of that. So the null has to have the equal sign. So we have to make the null greater than or equal to 3262. Okay, so are we okay with that step? Yes, no, maybe, sort of. Okay, well, it'll get easier as we go on. Okay. Now, okay.
Can you hear me at all?
Alternative hypothesis tells us the tail. So, which is it? Is it right, left, tailed, or two-tailed? Since it's less than, it's left-tailed. Right, Alicia, very good. It's left-tailed. Our alternative hypothesis tells us what tail it is. So, moving on. Step 2. Do we know the population standard deviation?
No. No.
We have to decide if it's Z, T, or proportion. Do we population standard deviation in this problem? If you didn't get a chance to work it out, what I'll do is send this to you on email. I should have done that before we started. But yes, it says in this problem the population standard deviation is 1100. So since we know the population standard deviation is a z-test, and z is equal to the sample mean minus the population mean over the population standard deviation over the square root of n. So our sample mean was 2995. That was given in the problem. That's where I got that from, okay? And then our other population mean was 3262. Population standard deviation, we divide that by the square root of 500. You can just use any calculator to figure that out. And I did already. It's negative 1.716. Yes, no, maybe on step 2. Since we know the population standard deviation, this is a z problem. That's hardly ever happens. We hardly ever know the population standard deviation. Okay, cool. Now I'm going to draw a picture for this. Here's what my picture looks like. Draw a normal curve. The mean is 3262. 2995 is over to this side. All we did was change this to the z-score of negative 1.716. This is the standard. We're changing it from a normal curve. We use the z-score using the central limit theorem to the standard normal curve. Sorry, standard normal curve to, no, I was right, I'm sorry. Normal curve to the standard normal curve. We're just translating it with the z-score using the central limit theorem. And we don't have to remember exactly what that was, but that's why we have the square root of n in this problem. So we already saw, I see when to choose T or Z. Great, great. Okay, so we want P. We want the probability. We want the area to the left. This is left-tailed. How do we know? Again, because our hypothesis was mu less than 3262. That tells us it's left-tailed. We go to our online calculator. Step 3. Okay, so I'm going to switch screens to my calculator. All right, I use my normal calculator, and I want to go below negative 1.716. Okay, I get 0.043. That's the probability that my score is below 2995. Okay, sorry for all the switching, but P is 0.043. Okay, now that's all you have to do. P low, null, goes. P low, null goes. So this tells us that since our alpha was 0.05, we wanted it to be a 95% confidence interval within 95%, and this is bigger than the 0.043, we reject the null. In 5, we just make a conclusion. Where did we get the alpha? It was in the problem. I'm sorry. Okay, the last sentence in the problem says, with a level of significance of 0.05, is the student senate correct? Okay, so they have to give you the significance level. Or if they don't, you always use 0.05. Alpha, yes. Yes, alpha is the significance level. Okay, so there is evidence to support. Oh, I don't know where that came from, sorry. You can't just erase a line, you have to erase the whole screen. How do you know when to reject and keep? Okay, if P is low, the null must go. If P is high, the null flies. That means it stays. So if P is lower than your significance level, you reject it. If P is greater than your significance level, you keep it. P low, null goes. P high, null must fly, but that means null must stay. Okay, so our null was less, that our mean was less than 3262. So we want to go with the alternative hypothesis. Okay, let's see. I see where to choose. How do you want? I, with the book, would say that in normal terms. Oh, I wish the book would say that in normal terms. That's why you have me, I hope. Good point. Okay, so those are the 5 steps. That should work in every problem. Don't I make it look easy? It's not that hard. It's just understanding all of it. Okay, I think the hardest part is just getting your hypothesis straight. Let's try, okay, I'm going to try another one. I'm going to give you a minute to copy this down. Again, I'm going to email you my examples, and then you can fill them in if you want to watch this again. I'm sorry for all this mess on the screen, but I can't just erase one line. The whole screen has to go. I don't know why they made it like that, but that's what they did. So, you want to move on, and then I'll give you some room to ask more questions. Would that be all right? Okay. Let's go to number 2. Okay, number 2 is about computer. So let me read it, and hopefully you can write some of this down. A high-end computer manufacturer retail their computers based in the manufacturing cost, which is $1,800. Based on a manufacturing cost, which is $1,800. However, the company thinks there are hidden costs and that the average cost to manufacture the computers is actually much more. The company randomly selects 40 computers from its facilities and finds that the mean cost to produce a computer is $1,950, with a standard deviation of 500. Run a hypothesis test to see if this thought is true. I'm going to give you some time to write that down. I'm gonna, like I said, I'll email you this right after. Right after. So what do you think the hypothesis is here? That's where I have issues. Yeah, that's no. This step one is okay. This is about computers. So let's go through this. What's n? Let's do the easy part first. So what's n? Yes, cost is more than. Yes, that's exactly it, Alicia. You're right. N in this problem is 40 computers. That's our sample. Let me read the first two sentences. A computer high-end manufacturer sets the cost, which is $1,800, but the hypothesis is what they think if it's different. Okay, let me try to bring that back up. Give me a second. However, the company thinks their hidden cost, average cost, is actually much more. That is your hypothesis. Your hypothesis is what they think it might be, not what they know. They know the average cost is $1,800. They know that. And they, in the example, well, they don't know that exactly, but they set the retail. They set the retail. Okay, so that's actual. So what they think is much more. That's your hypothesis. And you have a mean and you have a standard deviation. We know the population. Well, I'm jumping the gun here, so I'm going to go back to my collaborate. One, they think it's more than 1,800. So one of the hypotheses is more, but that doesn't have an equal sign. That's just greater than 1,800. So that has to be your alternative again. The mean is greater than 1,800, so your null has to be less than or equal to 1,800. Okay, so this is in the problem. Yes, it always has to be the opposite. The null and alternative always has to be the opposite. And the only reason I made that the alternative is because it doesn't have the equal sign. If it was greater than or equal to, or if it said they think it's at least 1,800, which means greater than or equal to, that would be the null. So the only thing that determines the null is the equal sign. It doesn't always have to be less than or equal to. It could be less than or equal to, or greater than or equal to, or equal to the null. But is it equal to? Yes, in this problem it is, because the equal sign is not in the alternative. Okay, so is that, what tail test is that? Yes, right. Good, Alicia. Because of this. your alternative always tells you right. Yes, Charmaine, great, great. So the second thing you do is ask yourself, do we know the population standard deviation? I'm sorry to go switch back and forth. Let me go switch back to the problem because it's important. Do we know the population standard deviation? Read the next sentence. The company selects 40 computers. The mean cost out of those 40 is 1950. The standard deviation out of those 40 is 500. So, no, we don't know the population standard deviation. We only know the sample. We only know the sample. The sample's 40, and the sentence right after that says it finds the mean cost is 1950 out of that sample, and the standard deviation was 500. So that's coming, it doesn't always say, I mean, that's what's hard about this. It doesn't always say population standard deviation, but this is in the same sentence. Okay, I mean, sometimes it does, but sometimes it doesn't. But it's in the same sentence. It says the company randomly selects 40 computers and finds the mean cost is 1950 with the standard deviation of 500. That is in the same sentence as the sample. That's telling you that's the sample mean and the sample standard deviation. Because it's in the same sentence. So, this is a T problem. Because population standard deviation is not known. And that's usually the case. We usually don't know the I mean, it's almost impossible to find that. So usually it's a T problem. Okay, so this is still number 2. T is your sample mean minus your population mean over your sample. It's really the same formula as before. So this is 1950 minus 1800 over 500 divided by the square root of 40, which is 1.8974. Okay. And I mean, this is not a normal curve, but we go to the T. This is step 3, the T distribution calculator. What is our degrees of freedom? (39), 1 minus n, or sorry, n minus 1, 39, because we had 40 in our sample. So let me switch to the calculator, and I'm going to go to my T calculator, and I'm going to and 39. Oh, sorry, T is, sorry, it's what I just found, 1.874. Again, I'm looking for the probability. My degrees of freedom are 39. This gives me a two-tailed answer, 0.0684. So I plug in the T value I just found. I plug in my degrees of freedom. It's 1 less than the example, which was 40, and 0.0684 is two-tailed. We don't have a two-tailed test here, though. We only have right-tailed, okay? So we have to be careful. P was 0.0652 is two-tailed, but our test was right. So you divide it by 2. Is P low or is P high? We have to decide if we should keep the null or reject it. It's low. So P low because it's less than 0.05. Let's write it like this, 0.05. They didn't give you that in the problem, but you use it if they don't give it to you. It's lower than your significance level, so null goes. So reject the null. And so there's evidence to support claim computers cost more than $1,800. Okay, we doing okay? Oh, the two tail or one tail. Okay, I'll go over that before I go over the last example. Right. If you're using the T calculator, the T distribution calculator only, the calculator that we use gives us a two-tailed answer. So the next example I'm going to do is two-tailed. But since our problem we decided was right-tailed, that's only one of them, we have to divide it by 2. But if this problem was two-tailed to begin with, and I'll explain that in a minute. No, it doesn't depend on ZT. Any of the 3 ZT or the proportion problems can be right-tailed, left-tailed, or two-tailed. What decides what kind of tail it is the alternative hypothesis. Our alternative hypothesis in this problem was that the mean was greater than 1,800. That means greater means to the right. So that says right tail. So it's only one-tailed, and that's why we have to divide it by 2, because the calculator that I use gives us a two-tailed answer. Now, you may be using some other calculator. Yes, less would be to the left, only on the alternative hypothesis. The alternative hypothesis tells us what tail it is. Step two is, okay, step 2 is the formula. All right, so step 2 is Z would be, it's the example mean. If you're using Z, The only difference between Z or T is that you don't know and then the proportion is P prime minus P over the square root of PQ over N. So those are your three types. Yeah, you have to decide what's given. This is if the population standard deviation is known. This is if you don't know the population standard deviation. And this is if you're given a percent or a fraction. Proportion is the same as fraction. So you have three formulas to pick from. That's step 2. You have to decide which one to use. Okay, so, and let me go back before I do this last problem, and we can do more again, like I said, but the alternative hypothesis decides the tail. So if it's less than, it's right-tailed. If it's greater than, it's left. If it's not equal to, it could be either one. It could be it's two-tailed. Okay, let me go back to, let's look at the last example I have. Like I said, I mean, I can get more, but I want to try to do one of each. Okay, so here the CEO of a large electric company claims that 80% of his million customers are very satisfied with the service they receive. Okay, so that's a claim. So to test the claim, the local newspaper surveyed 100 customers using simple random sampling. Among the sample customers, 73% say they're satisfied. Based on these findings, can we reject the hypothesis that 80% of the customers are satisfied? Use a 0.05 level of significance. Again, if they don't give you that, you always use 0.05. Okay, so I'm going to give you a minute, read it, think about what the hypotheses are. Okay, let's go back. %, say they are very satisfied, yes. That's among the sample. But what is the hypothesis? That is the actual test. So that's real. That's real. 80% customers, yes. 80% of the customers are satisfied. So that should be your claim. is 80%, because read the sentence. The CEO claims, we don't know that. We know the 73% are very satisfied because we sampled them. So your claim can't be something you sampled. Your claim can't be something you know. No, you can't, Robert. I'm going to answer your question. T is not, there's no usual. I mean, each one could be two-tailed, Z could be right, Z could be left. They could all be one or the other or two-tailed. It doesn't matter. They have equal chances of being left-tailed, right-tailed, or two-tailed. You just have to decide that in the problem. So if you said 73% is your hypothesis, that's not correct, because that's what you actually sampled. You already know that 73% are satisfied. So your claim is your hypothesis. A hypothesis is a claim, and it says it claims that 80% are satisfied. So your proportion, and we know it's a proportion problem because it's percent. So if they give you percent, it's a proportion problem. Or say A out of B people like this. So because that would be a fraction, A or B, and that you can change that to a percent. So we know, why do we know that has to be the null? Well, because that's the equal sign. That one has the equal sign, so that has to be the null. And the alternative then would be the opposite, automatically would be not 80. So this is two-tailed. Whenever you have equal or not equal, it's two-tailed. But that could happen with Z, it could happen with T. It just depends on your hypothesis. So once you decide where the equal signs go, then your other hypothesis, I don't care what it is, the other one doesn't have the equal sign. All right, now we go, I hope that's okay. So Z, we use the appropriate Z formula because we know it's a proportion. Now remember, Q is 1 minus P, so it's the opposite of P. So P prime is our 73. That's the sample. It's always the sample minus the population. In every one of the Z, T's, or proportion problems, your first number is your sample mean, or coming from the sample all the time. So this first number is always from the sample. Your 80% is the claim. So this is 80%. Opposite 80 is 20%. So those should add up to 100 or 1. And then we sampled 100 people. Okay, that was part of the problem, 100. And this is negative 1.75. And this goes back, this is a Z problem, okay? So this is normal. The only time you use the T calculator is if you don't know the population standard deviation. But here we know proportion, so this is going to be our this is normal. So the formula you use depends on what kind of problem it is. Okay, let's go to step 3. I'm going to draw a picture because we have a normal curve. We want on either side where the Z-score, this is Z, is outside of negative 1.75, 1.75. So we go to our normal calculator. I'm going to go to let's see, I use my normal. And I want outside of negative 1.75 and 1.75. So you look at the picture and you can see we want the probability that we're outside of there. Results are 0.0801. Again, this is we had to decide what kind of tail test it is, because that tells us whether we want below, above, or outside. Okay, we decided this was a two-tailed test, so we want outside. So 0.0801. So P, yeah, 8%. So is P high or low? Okay, what are you comparing it to? What number are you comparing P to? It's high. What you're comparing it to 0.05 is alpha. Okay, in this problem they gave you that. That's the level of significance. If they don't give it to you, it's still 0.05. So that is less 0.0. And let me write it this way, 0.0801 is outside of your level of confidence. P is high. Null stays. I mean, they say P is high, null must fly. That means when you say something flies, that means it's good. That's kind of slang. I just like to remember P high, null stays. I was using percent from here, the probability. That's the probability it's outside your confidence level. So you have to compare your probability to your confidence level, and P is higher than alpha, so P is high. P high, null stays. This is set in the problem. That's your alpha or confidence level. If it's not given, you always use 0.05. That's in step 4. You always compare it to that. Okay, so we accept the null. So there's evidence to support the claim that 80% are satisfied. Remember, our null was P equals 0.80. That was our null. Okay. Okay, so I'm going to give you a minute to think. I think I see, but maybe. No, it won't be different when you do the homework. Just make sure you're getting your claims straight. Make sure you know what your claim is, and if it comes from your example, then it's not your claim. Your claim is other than your example. You can email me questions, okay? I think I'm gonna, let's see, let me switch if it comes from the sample, not the claim. I don't understand. I'm talking about your hypothesis. Your hypothesis has to come from your claim, not from your sample space. I'm going to open up another document and walk you, let's see. Okay, I'm just going to, let's talk through this because I'll be able to see you chat with me. So we're going to just walk through this document. And it has the answers already because we're running out of time. I want to get as many examples as I can, so I want you to make sure you understand this. So don't look at the answers, just let's read through it with me. An inventor has developed a new high-efficient lawnmower engine. He claims the engine will run continuously for 300 minutes on a single gallon of regular gasoline. From a stock of 2,000 engines, the inventor selects a simple random sample of 50 engines for testing. The engines run an average of 295 minutes with a standard deviation of 20 minutes. Test the null, and it tells you that, but you should know right from here that the claim, as soon as he said he claims that the engine will run 300 minutes, that is your hypothesis. So notice right down here that the null hypothesis 300. So if the null is always where the equal signs go, so your alternative automatically is not 300. So this automatically tells you it's a two-tail test. So that's the first step in this problem. And I'll send you these also so you can look at these examples. Okay, so the next question. First, you decide the claim. That tells you your hypothesis. The alternative hypothesis tells you what the tail is. The null has to have the equal sign. Now, is this a T or a Z? Next question. Do we know the population standard deviation? I'm going to switch back to the whiteboard so I can see your chatting. Okay, I'll go back to my, I just wanted to check to see if you're following. All right, does everybody see this is a t-test? What tells you that it's a t-test is that here's the sample of 200 engines, simple random sample, and the sample standard deviation is 200 because it says the engines that he chose run an average of 295 with standard deviation. That's your sample because it's in the same sentence. So this is a t-test because we don't know the population standard deviation. And what tells you that it's in the sentence right after he chose the sample. So going through, we do the formula. Okay, the degrees of freedom are 49 right here. So it's the sample mean minus the population mean divided by the square root of 20 over 50. That's how we got the 2.1. 2.83. That's the 20 over the square root of 50. 20 is the sample standard deviation over the square root of n. So here's our t number. Now, okay, here's the t distribution calculator. We get the two-tail test. Is 0.04, so we don't have to divide by 2 because this is a two-tail test. We have a two-tail test, and our calculator for the t calculator does two tails. But again, if it was left or right, you would have to divide by 2. Well, they don't use the same calculator. So if we were to use our calculator, let me show you. Let's go to the trying to get to, okay, the t calculator. T was negative 1.77 degrees of freedom were 49.0829. So that's how they got this. We got 0.0829. Oh, that messed up. All right, so P is high. Let's go. We reject it. P high, reject. Oh, I'm sorry. P high, null stays. We cannot reject. Yes. P high is greater than 0.05. The null must stay. So we cannot reject the null. Okay, here's another one. We have 1,000 students. The average IQ is 110. You have randomly selected 20 students. The IQ is 108. Standard deviation is 10. Again, this is all from the sample. Based on the results, should the principal accept or reject her hypothesis? She thinks, okay, whenever you think something, that's your claim, is at least 110. That means 110 or more. So our null is greater than or equal to 110. The equal sign goes with the null. The alternative is the opposite. So you have to understand that her claim is at least 110. At least means greater than or equal to. Your minimum is 110. So the equal sign goes with the null. The alternative is less than 110. This is a right-tailed test because it's less than. So it's a one-tailed test. And actually, it's a right-tailed. This is also a t-test because in this problem, the 20 is your example. The IQ is 108 and standard deviation is 10. Out of that, we don't know the population standard deviation. So we find t, the degrees of freedom is 19. We do the example minus the population mean divided by the 10 square root of 20. Okay, we put this in our t calculator. And we get 0.019. P is high, the null stays. We cannot reject the null. P high, it's higher than 0.05. We can't reject the null. So again, I know that's really quick, but those are the 5 steps. Yes, I'm gonna email all of these to you. Okay? So, I know I went through those last two kind of quickly, but hopefully when you have the problem in front of you, it'll make more sense. So I'm gonna email all the examples, and I'll email you the one that I just did that it's all worked out, and then it'll be easy for you to follow the 5 steps. Okay, well, I hope that helped, and I hope you all have a great night. Okay, yeah, I hope you watch the recording. And also, email me questions. If you want to take pictures of your work, I can tell you where you went wrong, and maybe that'll even help you more. So, thank you for your time, because this is taking up your time too. So, thank you so much. And like I said, if you send me pictures of your work, I can help you see where you went wrong. I think this will make it a lot easier for you when you do the homework. And I'm going to email you that right now. So everybody have a great night.